Hey guys, today we got laws of logarithms or laws of logs. Laws of logs. Say that 10 times real fast. Logs of logs. Laws of logs. 3 basic laws of logs. And guys, remember, logarithms are the inverses of exponential functions. So the rules we had for exponents are the same as with logs or the inverses of them. So for example, if we have log with multiplication, we're going to split that up with addition. Think about what we did, what our exponent rules were for multiplication. We added the exponents. If you have division, you break it up with 2 individual logs with subtraction, just like we do with the exponents. If you have an exponent, remember if you had a power to a power, we would multiply the exponents. Same thing here. If you have a log with a number with an exponent, the exponent goes in front of the log, which means you're going to multiply the log by that exponent. Okay, so again, the 3 real quick. If you have multiplication, you add. Division, you subtract. An exponent goes in the front. It also goes backwards. If you see log with addition, you can make a 1 log by multiplying. If you have log with subtraction, you can make a 1 log by dividing. If you have a number in the front, it's really the exponent on the log. So they go both ways. Also, one thing about these laws, the bases must be the same. The bases must be the same. All right, evaluate these things. The first one says log base 4 of 2 plus log base 4 of 32. Now, we just learned if there's addition, that means you really multiply. So I'm going to do 2 times 32, which is 64. Now I'm trying to think, okay, 4 to what power 64? 3. That's evaluating. Part B. Part B has subtraction. Subtraction means I'm going to divide. So I'm going to do 80 divided by 5. Everybody knows that's 16. So now I'm trying to think 2 to what power is 16? The fourth one, the answer is 4. Part C. C's got a negative 1/3 in front. And if it's in the front of the log, that means it's sort of the exponent on the 8. All right, so that gives me 8 to the negative 1/3 power. First of all, the cube root of 8 is 2. So remember, bottom is the root, that's 2. But also it's negative, so I got to flip the 2 and make it 1/2. So that's just log 1/2. Okay, this says use the laws of logs to expand. So I'm going to try to make these into 2. This one's got, part A's got multiplication. So I'm going to break that up with addition, just like that. Part B also has multiplication. So I'm going to do the x cubed plus log base 5y to the 6. Now, those logs also have exponents. Anytime they have exponents, the exponents need to go to the front, like this. And there you have it. And then part C has a bunch of stuff. It's got a multiplication, division, root, everything in there. So here we go. We'll break it up, the top up with addition, like that. And then because there's a fraction bar, that means dividing, so I'm going to subtract. I'm going to put natural log cube root of C. Now, I would be done, except I don't like that cube root. Remember, bottom is the root, top is the power. Really, this cube root of C can be written like this. It's really C to the 1/3 power. So I'm going to take that 1/3, put it right there in front, and have that right there. All right, not that big a deal. All right, combine. Now we're going backwards. They're going to give you 2 big logs like this and ask you to combine into 1 log, okay, using those same laws. First thing I see is there's a 3 in front of this one, so that means it's the exponent on the x. Also, there's a 1/2 in front of this one, which means it's the exponent on the x plus 1, like this. Now, let's think about this a second. 1/2 power is an exponential power, which means bottom is the root, top is the power, which means that's the square root of that. And also, I see addition. So when I see addition, that means I'm going to multiply. So I'm going to go x cubed. This is 1 log, by the way. Log x cubed times the square root of x plus 1. Okay, and there it is. I put a question here, change of base. Okay, this is a weird problem right here. It says log base 3 of 7. And usually the way we've been rolling, I've been like, hey, 3 to what power is, 7. 3, you can't raise 3 to a power to get 7. You can, we just don't know what it is. Okay, so how are we going to find out? So what this really means, it means 3 to some power is 7. Watch what I do right here. When you don't know what power to raise something to get 7, when you need to know what an exponential answer is, when you need to know what the exponent is. Remember, the opposite or inverse of an exponent is a log. So what I'm going to do is I'm going to do log of both sides. I'm going to do log of this side and log of that side. And that's legal because whatever you do to one side, as long as you're to the other, you're in good shape. This on the left-hand side has an exponent. So I'm going to put that exponent in front of the log. So it looks like this. All right, now to get the x by itself, I'm going to divide both sides by log 3, and look what I've done. This is awesome. I know you don't realize this yet. That's really cool because when I started the problem, I had an issue because it was base 3. When I end the problem, because I didn't write a base, I use base 10. And the beauty of that is the calculator can do base 10. You can do whatever base you want to. I could have done log base. I could have been log base 3, log base 2. I could use ln, use base e. You can use whatever you want to. Base 10 is nice though because your calculator does it. That's why I chose just log. Okay, and here's the formula. Here's all you do. When you want to change the base, you can change the base anything you want to. You put the log of, I'm going to say the big number, the physically big number, the x, over log of the base. The base goes on the bottom. So again, if, like for example, if I see log base 7 of 5/8 and I want to change the base to base 10 so my calculator can do it, I would just do log of the 5/8, the physically big number, over log 7. The base goes on the bottom. This number goes on your numerator all the time. Okay, now the two most famous bases to change to are obviously base 10 because your calculator does it, but I promise you if you push in natural log 5/8 over natural log 7, you get the exact same answer. The base doesn't matter which one you change it to. Okay, let's try a couple here. It says use the change the base formula and common or natural logs to do each one. We'll do one of each here. The first one, it says log base 8 of 5. Don't know, like 8 to a power 5, I don't know. So I'm going to do log of 5 over log of 8. The base goes on the bottom. Punch that in my calculator, and I'm getting this 0.77398. All right, easy peasy. This one, let's do the different base this time. It says log base 9 of 20. I'm going to do natural log because your calculator also does natural log. So do natural log 20 over natural log 9. Punch it in your calc. Get 1.36342. And again, you could do either one of these you want to, anytime you want to. And the reason those are too popular is because those are the two that your calculator does. Your calculator knows base 10, it knows base C, makes it easy. All right. Hopefully that wasn't bad today. It's more log stuff, some laws. You need to know these though to do what we're going to do tomorrow. So make sure you get a good grasp on what the laws are. Add, multiply, divide, subtract, exponent goes in the front. See you tomorrow.